Good afternoon, my lovely Precalulus 11 class. I'm not here today, as evidenced by the fact that I'm not here, and so instead you're going to watch a video where I'm going to teach you the cosine law. This is following our sine law, which was yesterday. The sine law allowed us to see a relationship between the angle and the side, and today we're going to pursue that a little bit further by looking at another law. So let's go back and have a look at this particular triangle. We have been given an angle, which is 36. We do not have an angle here, and we do not have an angle here that has been given to us. We have one side across from the B angle, we have another side that's across from the C, and we don't have anything that is across from the angle A. So when we try to use the sine law in this case, where we put the side over top of the angle, so what we have is, I'm going to erase all of this again and say, all right, so I don't know what the side A is, but I do know that it's across from the 36-degree angle. So we put that up, we set up our ratio, we take our B across from the big B, and that is 6. We'll put that over top of our sine B, but we don't have that particular angle. And then the other one we have is our C. Now C angle is right here, and it looks to me like we have a side that's corresponding. So we have a 3 and we have a sine C. Now it says in the example above, where we are given the length of two sides and the contained angle, the sine law is not applicable. The reason we can't actually use this is because we do not have a link between the side and the angle. We have an angle, we don't have a side. We have a side, but we don't have an angle. We have an angle, but we don't have a side. So we can't solve. We have too many pieces of information that are missing. So what I want you to write here is, we do not have a link between side and angle. So this is not going to work. Like we learned the other day, we have to have at least we have to have 3 of the 4 pieces of information. And in this case, we do not have that. We have 1, we have 2, but we don't have 3 or 3. The same thing on this relationship. We have 1, 2, but we don't have 3, or we don't have 3. So it's not going to work. We have to come up with another plan. So let's investigate using SOHCAHTOA and see what we can come up with as we derive this new law, which is called the cosine law. So notice that, again, before you see this dotted line that's down here below, you notice that we, again, do not have a 90-degree angle. But if we do a little bit of arranging on this particular diagram, we could make a 90-degree angle, and that's exactly what we've done here. We have a 90-degree angle. Now, what we're going to first do is to find CD. So notice where CD is. It's the dotted line. It's the height from C to D. And what we'll do is we'll say in triangle ACD. So the one I'm talking about is ACD. In that particular triangle, we can go ahead and use our trig ratios. No law, no nothing, just sine ratio. We'll do our sine of 36 degrees, and that would be the opposite, which is CD, which is what we're looking for, and it would go over top of our hypotenuse, which is 6. What is CD then? Well, when we do that and we do a little bit of algebra, we'll find that it is 6 sine 36. What I did is just multiplied both sides by 6. And when I plug this into my calculator, I get a number of 3.5267. That gives me this side right here. And we know this side is actually A. So there we have that number. Now what we're going to do is we're going to find AD. AD, I'm going to take the highlight away and do it again. We're looking for this particular angle. This particular side. So to do that, what we'll do is in triangle ACD, what we'll do is we will find our cos 36 degrees. So now we're still looking at that same angle, but this time we're going to use cos because of course we want to have the adjacent. So we're going to go AD, which is what we're looking for, and we'll put it over the hypotenuse, which is 6. When I do that and I do a little bit of algebra and multiply both sides by 6, I'm going to end up with 6 cos 36 degrees, and that number becomes 4.8541. Now, what am I looking for? I am looking for the length of BD. So if I have AD and I have AB, I'm going to be able to find my BD. So how do I do that? I go BD equals AD minus AB equals, well, when we put this number and this number together and subtract it, we end up with 1.8541. Now I have this side. Great. Not quite done. Now what I'm going to do is I'm going to look for BC. BC, notice where it is I'll use a highlighter to show you. We're looking for BC. So to do that, what we will do is we will take now a new triangle. We're going to, in triangle BCD, we can now use the Pythagorean theorem because you're actually looking at this triangle BCD. We have a 90-degree angle here. We can use Pythagorean theorem, and we're going to be able to come up with what is the hypotenuse, which is BC. So BC squared equals BD squared plus CD squared. Plug in our new numbers that we have just solved for, and we'll square that. The CD was 3.5267. That's from above. I just solved for that. And when we plug this all in together, we end up with equals 15.8753. And of course, I'm looking for BC, not BC squared, so I take the square root of 15.8753. And I end up with an answer of 4.0. And it did say to the nearest tenth, so I need to make sure I include that 0 in the tenths column. So that method above is very time consuming. What did I have to do? I had to find a whole bunch of different sides, and I did. Then I was able to break down all of my triangles, and I eventually found my BC. However, there is an easier, faster way, and that's using our cosine law. So if you read at the bottom, it says the length BC can be determined in one step by using the cosine law. So let's do that. I'm going to turn the page, and let's have a look at this cosine law. The cosine law says in every triangle, we can use this particular formula to figure out what is missing in your triangle. The proof for the cosine law is here. I think what I'm going to do is I'm going to leave this on hold, and I'm going to derive this for you when I'm with you on Monday of next week. So what I'm going to do instead is we'll put this on hold for the time being, but what we will do is we're going to actually use the equation, the law, and go ahead and put it into practice. And then, as I said, we'll come back on Monday and I will show you the proof. That's part of pre-calculus, is for me to show you how I derive formulas. So we're going to put it on hold. What we're going to say is, hey, let's just use these laws, and I'll explain how we use the cosine law as we go through a question. So here's the question. It says that we have this triangle. I'm looking at this triangle right here, in which we've been given an angle, 36. We've been given a side, which is AB. We've been given a side, which is AC. And now I have to figure out the BC length to the nearest tenth, and I am going to use the cosine law. So we could do it like we just finished doing it on the other page, but instead we're going to use the cosine law. So what we're going to do is we're going to use this formula. A is representing the one side that we're actually looking for right here. This is A, and the formula goes as such. We take one side and that will equal the other two sides squared. Then what we're going to do is we're going to take the two sides, multiply them together, and multiply them with 2. So we'll take our B and we'll take our C side. And then here we have our angle, which has been given to us. So we have one angle, which was the 36 degrees, and then we have the other two sides that have been given to us. Would you also take note at this point that the angle is in between the two sides? They are contained by the two sides. So 30 degrees is here, and it's between this side and this side. And that has to be the case when I use the cosine law. So then all I do is I start substituting my numbers in. Again, I'm looking for the A side, which is of course also known as BC. So I plug in my numbers, which are just found on the diagram. And I put in my angle for A, which is 36 degrees. When I do all of that and plug it in, remember you need to multiply these guys all together, what I've just underlined, and then go ahead and subtract it from the 36 plus the 9. So once you do all of that, and I would like you to take a moment to try that on your calculator, 15.8753 ... There's a few more digits after that, but it does say in the question that we need to take it to the nearest tenth. So A is going to equal, and of course the square root of the 15.8753, I should get 4.0, and that's to the nearest tenth. All right, so we've got that. So BC, which is what we were asked for right up here at the beginning, what is the length of BC? And we can do that using a very simple formula, and that is the cosine law. All right, we're going to just continue. We're going to just do 2 more questions and then we'll stop. The next 2 questions, again, very similar. You're given a whole lot of information and you need to find a side or an angle. And in this case, it says find the length to the nearest length of a centimeter of the third side of the triangle PQR. So PQR is the triangle. We know what QP is. QP is 1.7. We've got QR, which is 3.1. Notice that the angle is given. Remember, it's always the letter in the middle of the 3. That tells me which angle I'm looking at. So I'm looking at angle Q. It is right here, and it's 110 degrees. Once I have that, then I can go ahead and I can find the missing length, which of course will be this side right here. And we're going to call this side little q. It's always the lowercase across from the angle. So I'm looking for little q. So the formula goes as such. We just take the one that we're looking for, which is out front, q squared. And I'm going to take my, let's call this r. R equals 1.7. And this 3.1 should be p. P equals. So knowing that, we can go ahead and go r squared. I'm going to just take that line out. R squared plus P squared. Then we go ahead, put it in the formula, put the R in, put the P in, and then of course it's cos law, so we're going to use the cos of the angle that they have given me, which is 110. Now, what is QR? Well, remember it is also known as PR. So I'm just going to go throw in PR squared. It's the same thing. R squared is going to be 1.7 squared plus 3.1 squared minus 2. Now the R is 1.7, the P is 3.1, and the cos of 110. And again, that's not using your second function. That's just going ahead and coming up with the actual trig ratio. plug all of this together, and I end up with, again, try it on your calculator, make sure you know how to do this, keeping in mind your bedmas, and we end up after